Good day, sir. I'm Carly Sibano from BCME. For now, I'm going to discuss about the properties of gases, especially air. Air properties definitions. Air is a gas. It contains of 78% nitrogen, 21% of oxygen, traces on H2O, carbon dioxide, and argon. So property and dimension and values. As we can see, the property of gas is mass, volume, density, specific volume, pressure, temperature, viscosity. And the dimension, the dimension of density is mass over volume. The dimension of a specific volume is volume over mass. The dimension of pressure equals to force over area. The dimension of temperature is degree. The dimension of viscosity is force minus time over area. The volumetric of density equals to 1.229 kilogram over meter cube. The volumetric of a specific volume equals to 0.814 meter cube per kilogram. And the volumetric of pressure equals to 101.3 kilonewton over meter squared, and the volumetric of temperature equals to 15 degrees Celsius, and the volumetric of viscosity is 1.73 times 10 raised to negative 5 Newton minus slug over meter squared. From now on, let's proceed to gases. So what is gases, or what is gas? It is a substance or matter in a state in which it will expand freely to fill the whole of container, having no fixed shape unlike a solid and no fixed volume unlike a liquid. Hot balls of gas that become a star. Gases also do not possess any definite volume or shape. They totally fill all the space accessible to them. The characteristic or properties of gases to fill the available volume within a container is the result of the freedom that gas particles have now move everywhere in the accessible space. This autonomy of movement of gaseous molecules is because of the very weak binding forces amidst molecules. In other words, their intermolecular forces are very weak. Because of this, the molecules of a gas are in a continuous motion and are related to high velocity and therefore high kinetic energy. Next is the properties of gases. So what are the properties of gases? First, compressibility. Second, expansibility. Third, diffusibility. And fourth, low density. And the fifth is exertion of pressure. So what is compressibility? Compressibility. Particles of gas have huge intermolecular spaces in the midst of them. By the exertion of pressure, much of this space can be diminished and the particles are brought closer. Thus, the volume of gas can be hugely reduced. This is termed as compressing the gas. So, as you can see, this picture is one of the example of compressibility. Compressibility also is a measure of the relative volume change of a solid or a fluid in response to a pressure change. So I have four examples of practical applications which in based on high compressibility of gases are. So first, an LPG or liquefied petroleum gas cylinder, that gas is compressed and it is a fuel which is made up of petroleum gas. Hence, by compression, large quantity of gas can be contained in the cylinder. The second is in oxygen cylinders in the hospitals have compressed gas filled in it. And the third is in CNG or compressed natural gas. It is a natural gas methane which is compressed and used as a fuel in vehicles and at home. And the fourth is in tires. The gas is compressed to fill the tube of vehicle, which creates pressure. The second properties of gases is expansibility. So, what is expansibility? Expansibility when pressure is exerted on gas. It contracts. On the other hand, when pressure is spread, the gas expands. When the temperature is augmented, the constituent particles gain more energy, travel faster, and move away from each other. Consequently, the intermolecular pull becomes less prominent. The gas volume increases. Expansibility are also the quality of being expansible, capacity of extension in surface or bulk, or of distension, as the expansibility of air. As you can see, this picture is one of the example of expansibility. The third properties of gas is diffusibility. What is diffusibility? Diffusibility, the molecules of the gas are in perpetual motion at a very high velocity. There is a huge amount of intermolecular space amid the molecules. When two gases are mixed, particles of one gas can effortlessly pass through the intermolecular space of the other gas. As an outcome, both the gases get completely and consistently mixed. Thus, a mixture of gases at all times remains homogeneous. Diffusion also describes the mixing of gases. The rate of diffusion is the rate of gas mixing. Molecules move from areas of high concentration to low concentration. As you can see in the pictures, you can see the high concentration movement of particles and the low concentration. The fourth properties of gases, which is the low density. So, what is low density? Low density, since gases have large intermolecular spaces, they have very large volumes when compared to their mass. Therefore, they have less densities. If 1 ml of water at 39.2 degree Fahrenheit is transformed into steam at 212 degree Fahrenheit and 1 atmosphere pressure, it will occupy a volume of 1700 ml. Gases also have low density, much less than liquid or solids. Because of the large distances between gas particles, most of the volume of a gas is empty space. Gas particles travel long distance before colliding with each other. And the last properties of gases is exertion of pressure. What is exertion of pressure? Exertion of pressure. Solids exert pressure only in the downward direction. Liquids apply pressure downward as well as to the sides, but gases apply pressure in all directions. A good example is a balloon. This pressure is because of the bombardment of the particles against the walls of the vessels. So let's proceed to variables that describe gases. So, what are the variables that describe gases? There are four variables used to describe gases. First, pressure or P. Second, volume or V. Third, temperature or T. Fourth, amount or N. First, pressure. Units of pressure. The standard unit for pressure is atmosphere or ATM. Other units include kPa or kilopascal, mmsg or millimeter of mercury, torr or torricell, psi or pounds per square inches. Second, units of volume. The standard unit for volume is liter or L. There are 1000 ml in 1 liter. Third is in temperature. Units of temperature. The standard unit for temperature is Kelvin or K. Other units includes degree Celsius or C, degree Fahrenheit or F. Also, absolute zero, the theoretical temperature at which all kinetic motion completely stops, equal to 0 Kelvin or negative 273 degrees Celsius. So conversions. Kelvin equals to degree plus 273 or degree Celsius equals to Kelvin minus 273. That is all, and thank you.